Okay, one thing I want to make sure you have, you guys all have your calculator today?
Yeah.
She's actually
All right, maybe just kind of bounce back and forth with this, okay? Guys, today, honestly, not a hard section. I think a lot of the things that we've covered so far in chapter 9 have been things that we've touched on a little bit. Today what we want to do is polish up your skills on the last part of right triangles. I think you guys have done a really good job with the sine and the cosine and tangent. I think prior to that we did some good things with altitudes. I think the altitudes was probably the hardest section that we looked at. But today our last section is to solve right triangles. And the question says, when you know the lengths of the sides of a right triangle, how can you find the measures of the what? The two acute angles. So I just want to think on this, kids. We've talked about in the past that if I know two angles of a triangle, then you actually know what? All three. Because if you know two, you can find the third one. All right? So we're going to talk about how, if I know the lengths of the sides of a right triangle, how do we find the measures of the last two acute angles? And one thing that's going to pop up today a lot, and we're really going to focus on, and this is a biggie for our goals, use inverse trig ratios. That's going to be really important today, okay? We're going to use inverse trig ratios to help us solve right triangles. So kids, here's what I'm going to tell you. It says, first of all, for vocabulary, inverse tangent up here. It says if the tangent of angle A is equal to some value x, then what? How do I read this right here? Tangent inverse. This is read as tangent inverse of x is equal to the measure of angle what? Going from this step right up here to this step down here, what two variables switch spots? X and A did. Okay, so here's the deal. I don't know how to draw this. I'll say, let's put a right triangle in here. Okay, what function are we dealing with, kids? Okay, so let's say that angle A is right here. I don't know. How about I call this x and I call this 1? Do you guys agree that the tangent of angle A is equal to x over 1 there?
Yeah.
Okay, so what that would say then is this. The inverse, this would say then the inverse of this side x over 1, or this ratio x over 1, would equal angle what? A. And we'll look at some examples like this here in a little bit. There's not really too many pictures to put in here today, all right? What inverse tangent does is it allows us to find an angle, okay? And maybe I should write this down. Tangent inverse of some value gets us an angle. And I could say the same about all of these, all right? The inverse sine function is going to get you an angle in the end, okay? These are all the same exact thing. They're just the different trig functions. So like in the second one where it says inverse sine, it says if the sine of some angle is equal to what, kids? X. Then the sine inverse of x is equal to? Let me give you an example. Do you guys have your calculators handy? Type in, let's pick a good one. Type in sine of 30 degrees in your calculator. 0.5, right? Now, do this for me. Type in your calculator sine inverse of, whoops. Type in sine inverse. Now, does everybody know how to get that inverse? Some of you might have to hit like a second function key. Then type in sine inverse. Now, what happens when we invert stuff, guys? What do we do with values? Flip them around. So the sine inverse of 0.5, if I have the sine inverse of some ratio of 0.5, what's that kick out? That means it's 30 degrees. So if you ever have a ratio for a sine function of 0.5 and you invert that, that means the angle you're talking about is going to be a 30-degree angle. Okay? So do you see the relationship up here? When you punched in sine 30, what'd you get? 0.5. When you punched in sine inverse 0.5, what'd you get? Okay. Using inverses gets a what? an angle, okay? Not going to go on about inverse cosine because it's the same exact thing as the top two. We just need to figure out which of the three trig functions we're going to use, and I'm going to show you that in some examples here in a second, okay? All right, solving a right triangle, kids. How about a volunteer to read that lengthy definition?
To solve a right triangle means to find all unknown side lengths and angle measures. You can solve a right triangle when you know either of the following: two side lengths, one side length, and the measure of one cubic.
Okay, here's the deal. We can solve right triangles if you know what?
Two side lengths.
Two side lengths, or what else?
One side length and the measure of a cubic angle.
Okay. These are pretty important right here. You might want to highlight these, okay? What they're getting at is this, kids, to solve a right triangle. Well, first of all, kids, in a right triangle, what angle must exist? So if I label this like triangle ABC like this, okay, if I label that triangle ABC, then I would say opposite of side A is little a, opposite of angle B would be little b, and opposite of angle C would be little c, like that, okay? If I know two sides, I can solve the whole thing. Or if I know a side and an acute angle, I can solve the whole thing. Now, what does solving mean? Solving means you know how many angles. One of them, two of them, or all three of them. Solving means you better know all three. So we're going to have to solve for angles. Now, angles, are they denoted by capital letters or lowercase letters? And then sides are going to be denoted by little letters. So how many answers are going to solve a right triangle? 3 angles and 3 sides. So really, solving a right triangle is going to have how many solutions? 6 of them, okay? You're going to have 3 angles that we're looking for. One of the angles will always be what, since we're solving right triangles? We know C is 90. This will be some number. This will be some number. And then for sides, we're going to have to find all sides. These are going to be some number. Okay? The thing I want you to understand today, using inverses, or I'm going to say inverse trig functions, helps us solve for angles. This is going to be the big idea today, all right? I can use an inverse trig function for finding angles. Now, if I'm finding sides, I use the normal trig function. Use normal trig function. Solve for sides. I need your practice standpoint 5, Jonathan. Okay. Okay. So which one helps us find angles, kids? Normal or inverse? And what's going to help us find sides? And you guys have done a really good job about finding sides lately, right? So that part isn't going to change for you. The part that's going to change is helping us find what? Okay. All right, so let's take a peek at the second page and see what we can run ourselves into here. Ooh, identifying angles from trig functions. All right. It says, determine which of the two acute angles has a sine of what, kids? Okay, well, first of all, my question is this. Which two angles are my acute angles?
Q and R.
Okay, Q and R. So I'm going to make a T chart right here. All right. Let's put angle Q up here. And let's put angle R right here. So we need to determine which angle, Q or angle R, has a sine value of what, kids? 0.4. All right, let's try this. How about the sine of angle Q first, kids? Sine of angle Q would equal what over what? So 321 over. All right, so let me get my calculator out here. So I'm going to go 3 times what, kids? So I'm going to type in 21 square root times this by 3. That's that. Now what do I have to divide by? What do I get here? So is angle Q the right one? All right, so let's go to angle R. So if I was looking at the, which ratio am I looking at here for this question?
6 over 52.
So I'm going to go sine of angle R. All right, so let's see what 6 divided by 15 gets us.
4.
Oh my gosh, really?
Oh my gosh, really?
So the sine of angle R is equal to what?
1 4.
Okay, so which one is it?
R.
Yeah. It's going to be angle R right here. That's the one. Okay, angle R gets us a sine of 0.4. Okay, now let me show you why that's important. Okay, I'm going to put up here in red. This is important. Why is this important? Why is the sine of R 0.4 important? Okay, well here's the deal. We can use that ratio now to do an, what's the word I'm going to use? Inverse trig function to find angle R. Okay, this is a pirate's favorite problem. Trying to find the measure of angle R. All right, Hookie. Angle R? R. You know why the pirate didn't go to the movie? It was rated R.
You would have done.
Lincoln, how much does a pirate pay to get his ears pierced? A buccaneer. Ah, that was good, wasn't it? You guys look at me like I'm some kind of dork.
I like that one.
All right, here we go. Why is this important? Here we go. I'm going to invert this. Right down here, I want you to write this down. Write down sine inverse of what value when I switch stuff, kids? 0.4 is going to equal the measure of angle. We switch the 0.4 and the R around when we do the inverse. Punch that in. What do inverses help us find?
Angle.
Type in sine inverse 0.4. Give me an answer to the nearest tenth.
23.6.
What this is telling me, guys, is R is how many degrees? Here's the deal, kids. Once I know right in here in this problem now that R is 23.6 degrees, is there enough information to find this angle? Well, what would you do to find the other angle? You already have 90 right here, so don't the two acute angles have to add up to 90?
Yeah.
So take 90 and minus what? What does that equal?
66.4.
Guys, using that inverse right there, I have a question. Look at that triangle now. Do I know all 3 sides?
Yes.
Have we done enough work to find all 3 angles? So when we're talking about our notes or in our lesson here that solving right triangles, is that right triangle solved?
Yeah.
Why is that right triangle solved?
So you know all 6 answers.
We know all sides and we know all angles, okay? So what I'd like you guys to do is to get used to your inverse function, okay? I want you guys, all right, they're saying the tangent of some angle right here is 3.29. They're saying the sine of some angle is 0.55. They're saying the cosine of some angle is 0.87. I want you to use your calculator in inverses to find the measure of those angles right now. So you're going to do the tangent inverse of what value first to find angle A? 3.29. You guys find those 3 quickly. If you're confused, talk with someone around you. Have them help you through it. You've got 3 answers to find. And the time it takes me to get back, have them.
Trig, okay. We're gonna keep going down further. So you see your sign inverses there now. So you're gonna option 4 and then type in your decimal of 0.4.
Okay. All right, and the time it takes me to get back, have those, all right? 66.4 because I know that's 90, so this and this one there. So I took 90 minus 23.6 to get the other one.
Quick question.
Yeah.
It says arctangent, is that?
That's same thing. Arctangent, same thing.
So we put that in.
Do you put like Y?
This is the only elective open.
I go to handle yesterday too. Someone wants to do that. I thought it was over the goal. And then like right by like the name. So you just pull it out like that. And I wasn't
But
like,
it's a fact, so.
Have you got it, kids? Tangent inverse of 3.29. What's that make angle A? All right, so if I do this right here, guys, the way you type this in is tangent inverse of what value? And that's going to tell you the measure of angle what? Again, inverses. If I use trig inverses, what's that telling us? Angle measures. What'd you guys get? So I say a measure of angle A is 73.1 degrees. How many had 73.1 degrees there? Okay. Volunteer for 2. I'm going to do the sine inverse of what? .55. That's going to equal 33.4. So my angle B, 33.4 degrees. How many are agreeing so far with those two? All okay? Somebody talk me through the last one. I know that the cosine of angle C is 0.87. The cosine ratio of angle C is 0.87. How do I use that information to find the measure of angle C?
Inverse cosine. So then 0.87.
And what's that going to equal?
29.5.
So when I set that angle to equal C, run that by me one more time so everybody hears you, Grace.
29.5.
29.5 degrees. Give me a show of hands. How many had all three of those? Very good. Okay, so do you understand how to use the inverse to get an angle? First question. Everybody good on their calculator, punching that stuff in, coming up with those values? All right, let's steam ahead here. And so in example 3, it says to do what now?
solve the right triangle.
This is our goal today. How do you solve right triangles? This is what we're trying to accomplish today. So this example, I'd say it's kind of important. All right? That's my little union star. Twinkle, twinkle, union star. Says to do what, kids? Solve the right triangle. It says round decimal answers to the nearest what? 10. Okay, I'm going to put my answers over here in the box, but I'm going to Well, do some work below that. So I'm going to make a chart like this. Okay, we need to solve, if I solve for a triangle, what's that mean to do? Need to know all three sides and all three angles. So here's how I think we should go about setting this up. I'm going to put angles here. I'm going to put sides here. Okay, are you with me on this? Okay. Angles are going to be denoted by capital letters. So I'm going to put capital A, capital B, capital C. Over here, little a, little b, little c. Now understand this, kids. Angle B right here is how many degrees? 90. Which side is across from the 90-degree angle? 25. So we always relate opposite sides and stuff like this. So I say little b is what value? Okay, do I know any other angles? Do I know any other sides? Would that side be small a or small c? Okay. Hey, let's take a look at this. We can solve right triangles if I have either two sides or a side and an acute angle. Can I solve this triangle?
Yeah.
Why?
Because you have two sides.
Because I have two sides. Okay. What do you guys want to solve for first?
Short side.
Short side?
Short leg.
Short leg. Short leg would be side C right here, right?
25 squared minus 24 squared.
So 25 squared minus, so let's do side little c. I can say c squared equals 25 squared minus what? All agree? All right. So c squared is 49. What's that make the c value? So have I solved for all three sides? That's good. What else do we need to figure out? And if I'm looking for other angles, we're going to have to use an...
Inverse
I'm okay.
An inverse function.
Is that caffeine?
Did you guys look at me like I was crazy? Or?
I was trying to figure out
Yeah, the caffeine's definitely
in
hitting.
my mind what
Inverse.
I did. I already have all.
That's the point right
There's
there.
caffeine in this too.
Hey, can I tell you the angle sides?
So yeah, you want to talk me through it so everybody understands here? Okay, which angle are you working on, I guess? Maybe that's the better question. Are you working on angle A or angle C that we don't know? Okay, so Sonny's chosen to work with angle A. All right. Angle A. What do you know about angle A right here?
Its opposite is 24.
Is that what you're going to say?
Yeah.
All right, carry on. So 24 is opposite. What else do you know? The hypotenuse right here. So you know the hypotenuse. You know the opposite leg. So Sonny, what can I say about angle A related to the opposite leg and the hypotenuse?
Well, I just did like sine of angle A equals 24 over 25.
Well, I totally agree with you. You're saying sine of angle A was what?
24 over 25.
24 over 25. All right, let's talk about that. Sine of angle A. Guys, reference yourself at angle A. We are up here, top of the triangle. You guys agree that the sine of angle A would be the opposite leg length 24 over the hypotenuse 25? Sonny, can I ask a question? What's 24 over 25 divide out to be? So the sine of angle A is 0.96. How am I going to progress with what I have there? Yeah, we're saying the sine of angle A. I don't know the angle, but I know its ratio is point what? So how would I use that information to figure out what the value of angle A is? This is where we're going to inverse this puppy. So at this point right here, we're going to go sine inverse of what value? So Sonny, put it together for me. When you inverted 0.96, sine inverse 0.96, what did you get to the nearest tenth of a degree?
73.7.
73.7 degrees. Well, okay. Quick question here then. If angle A is 73.7 degrees, that's a 73.7 degrees up there. Kids, we've talked about the idea that if I've accomplished two angles, you really know what?
Those are 16.3.
Yeah, because 90 and 73.7 added up, subtract from 180. Or you could just take 73.7 from 90 and that would get you what? To which this point right here now, guys, is the triangle solved?
Yeah.
And why is the triangle solved
I
again?
know everything about it.
You know all angles and you know all sides. And the reason we were able to solve this is because we had what in the beginning, kids? In a right triangle, we knew two sides. All right. Good job. Give yourself a pat on the back. Everybody have what they need there? Questions to the end of the second page. Who's ready to roll on to the third? Let's finish this up, kids. This is good stuff. Gosh, I love this stuff, okay? I want to see what you're able to do with this. So I want you to take a couple minutes, set your chart up, like so. I like to do my angles on the left, so angle A, angle B, angle C. Always put in what's known first, kids. All right, what do we know? Oh, shoot, I screwed up, guys. I screwed this up. Back up. We don't have A, B, and C in here, do we? Yes, you guys let me get all the way through that and nobody stopped me. Okay, I'm going to divide this up. So what are my angles, guys? All right, what angles do we know?
You know, X.
X is,
41.
Z is,
90.
And X is
don't worry about Y just yet. Okay, how about little x? Do we know little x?
No.
Don't know that. Do we know little y? Do we know little z? Little z is across from capital Z or angle Z. How big is?
18.4.
Okay. So in this case, we know a side, but we also know another acute angle. Can I solve the rest of it if we have that given information? Okay, you guys carry on. See what you come up with. Help each other through it. I'm going to give you 3 minutes and 14 seconds to complete this.
Angle Y is 59. No, it's not. It's 59.
Tell me what you come up with when you've got X and Y. Now again, the only time you're going to use inverses is if you're finding an angle, but in this case, is it necessary to use inverses at all?
No.
No, because can you find that last angle easily?
Heck yeah, you can.
Okay, and then revert back to what we did in the last section. Just use your sine and cosine stuff to find one side. Kids, walk me through this. Let's do the angle first. Is it possible to do angle Y here?
Yeah.
Okay.
49.
How'd you get 49?
Because I subtracted 41.
You know two angles, and you're going to know three. So yeah, 49 is the difference between 90 and 41. How many had 49 degrees? That's my first question. I'm sorry, how many had 49 degrees? I didn't catch that.
Yeah.
Everybody did? Okay. Okay, how about thoughts on, boy, I don't know where to put my work to solve for x, so I'm just going to pick a new page here. Well, actually, I can find out. How about thoughts for finding the length of x?
Sine of 41 equals x over 18.
Oh, wow.
Sine of 41 degrees, because that's a good reference. X over what?
18.25.
Awesome. X equal over 18.4. Okay. So when you solve that mess, what do you guys come up with?
12.1.
12.1. Yep, we would decimal this out. And thanks, Joe. Did you find yours? Yep.
Yep.
Okay. All right. I'm sorry. What was that again, kiddos?
12.1.
12.1. Hey, quick question. Does it make sense? Does it make sense that 12.1 would be shorter than 18.4 here? Okay, because 18.4 is my. Okay, how many agree with the equation that was set up here? What equation could I set up to solve for y?
Same thing with different variables.
Same thing, different variables. Could I use 41 degrees? Relative to 41 degrees, how is y related?
It's easy.
Yeah, it's an adjacent leg, so therefore I can use cosine since we know the length of the. Okay. All right, so help me out. Cosine of
41.
y over. What'd you guys get there? Hopefully more than 12.1?
13.9.
I want to make a relationship here. Let's set some goals. Let's have goals. What's the smallest angle up here? X, Y, or Z? What's the shortest side? What's the largest angle up there? What's the longest side? There will always be a relationship. If the order of angles goes X, Y, Z from least to greatest, then the order of sides should go little x, little y, little z from least to greatest. Okay? That's one way to kind of know you're on track. All right, last example. Let's finish this up and then we'll move you on out of here for the day. Hopefully you guys got your win time selected so the slack attack can't get you attention.
Only weird freshmen call it
I'm sorry?
that. Only weird freshmen call it that.
Slack attack?
Yeah, I call it.
I call it slack.
Weird freshmen.
All right. Your school is building a, what's that say, rate?
Yeah.
Stage? The stage will be how long? 30 feet from, I'll blow this up quickly. It will be 30 feet from front to what?
Back.
Okay, so 30 feet from front to back with a rise of how much? It says we want the rake elevation to be how many degrees? Okay. It wants to know, is this angle right here, is this within your desired range? So it wants this to be 5 degrees or what? Less, okay? Do you guys agree that we're trying to find the angle at the stage front? Okay, the angle of elevation has to relate to the horizontal, so this is the angle we're really concerned about. Let me get a different color up there. This is the angle we're really, really worried about right here, okay? Now, if that's the angle I'm working with, kids, which two sides relate to that angle? 2 and what?
30.
So we have to find that angle measure, hoping it's 5 degrees or less. What function would I use here? Let's call this angle A. Is that okay, kids? Okay. So we're going to say the sine of angle A right here equals what over what?
2 over 3.
Okay, so here's the deal. What we need to do is when I have two numbers like this, but I don't know an angle, we need to turn that fraction into a,
Yes.
and let's go how many places on that decimal?
4.
So we're going to say the sine of A
7.
equals what, kids?
0.66 or 0.7. 0.
0.0667.
Whoops, let me back up. 0.6.
0.0667.
So what are we going to do to find that angle measure given our dimensions of our stage so far? So let's go sine inverse of
Oh my gosh,
what is the sine inverse of 0.0667? 3.8. So A is equal to how many degrees? Which is less than what? Is that a good thing or bad thing? We are good to go. Okay. Kids, what questions do you have on this? You understand that inverses are used for finding what? Angles. And in a relationship of like angle A, side A is adjacent to it or opposite of it? Opposite. Okay. All right, very good. Kids, I sent